Welcome to code.py. In this series, I'll be covering the coding interview questions that I've encountered during the actual interview from topics ranging from recursion, lists, arrays, etc. I'll be covering very basic problems as well as the complex ones related to the topics across videos, and I'll try to share the solution that worked for me. I don't claim the solution to be the best, nor do I claim that the problems that I'll be covering are the only ones to be encountered in that particular area. However, the intention is to try to help others who are looking to prepare for the coding interviews with Python. So please feel free to share your suggestions and help in case you have a better or an efficient solution for the problems that I'm discussing. In this video, we'll be writing a Python code to generate Fibonacci numbers for a given position using recursion. So basically Fibonacci is a series of numbers where the sum of the last two numbers gives us the next number. So the series goes like 0, 1 and then the two numbers get added up to give the third one, and then these two get added up to give the next one, and so on. So it only works with positive integers. So as a part of solving it through recursion, there are three main criteria for recursion that we need to keep in mind. One is the recursive case or actual recursive representation. So clearly we can see that Fibonacci can be represented in a recursive case like this, where the Fibonacci for any position n, Fibonacci number for position n can be equal to the sum of Fibonacci number for position n minus 1 plus Fibonacci number for position n minus 2. Also, the base condition for the Fibonacci series, or basically the seed to start the series, already clearly says or clearly showcases that the first element Fibonacci 0, if we can call it that way, Fibonacci 0 will be 0 and Fibonacci 1 will be 1, and then Fibonacci 2 will be 0 plus 1, that is 1 again, and so on. So this is the base case which we have to keep in mind. And then the third thing, the edge case or any constraints, like I already mentioned, it is only for positive integers, and we have to make sure our solution caters to a scenario where the user passes let's say a negative integer or a decimal number. So without further delay, let's get started with the actual code. So I'll define straight away define the Fibonacci function. So let's call it definition Fibonacci Fibonacci of number n, and let's write the actual Fibonacci recursive case directly. So let's say the function will return return itself with value n minus 1 plus and the value of n minus 2. So this is basically the very nutshell of the function, and this is how we expect the function to behave. So but of course this is not going to suffice, so we have to add the base case as well as the edge cases. So before that, let's try to see if we get the desired output using just this bare minimum condition. So I'll be creating the main body, and then from there I'll be seeking an input from the user. Input, enter the value of n. Okay, now one thing to check is and in fact before that, let's try to straight away call the Fibonacci and print the output. So print Fibonacci, and I will pass the value n, and that's it. Let's try to run this function. So if I try to run this function for, let's say, a value 3, okay, the first thing is, of course, the input that I'm expecting, it has to be an integer. So let me cast it to an integer. So let's try to rerun it. Value of n2. Now we can see that we are getting the recursion maximum recursion depth exceeded error. The reason for that is we haven't considered our base condition. So let's add the base condition here. So if n in 0 or 1, so if n is either 0 or 1, we should return the value of n. If it is 0, we should return 0. If it is 1, we should return 1. And only in the other cases we have to return the recursive call to the function. So after adding this base condition, let's try to run it for 2. Of course the second element, so 0 1 2, so second element is 1. Like I mentioned, we are counting from 0. If you don't want to count from 0, or if you want to consider the value of n as the kind of positive integer position of the value, so then we can change the base condition to 1 to 2, but it may add some confusion. That's the reason I wanted to keep it this way. So that's basically it's working now. Now the problem here is what we are already assuming is that the input from the end user will always be an integer. Let's try to see if our but without making any changes, if our edge cases are working in this. Of course they won't work, but let's see what we get. So again, with -1 we are getting the maximum recursion depth, because it keeps on increasing with the negative numbers we are adding to it. So the negative scenario isn't working, as well as if I put a decimal, it will say that the conversion of this integer failed. So to handle this, let's create another function where we can explicitly check for the number to be an integer. So definition is int, let's say this is our function. So basically what we have to do is to check. So let me try to convert it to, or cast it to an integer, int of n. So the number I'm trying to cast it to integer. If it will fail, it will go to the except block, and if it, we will add the code to the except block later. So if it fails, it goes to except. If it passes, then of course it will basically work for us. So we can say return true. So it is proven that it's an integer, and in the except block we will say that it is not an integer, so we will return false. So this function should be good enough for us to check for the integer part. So okay, let's call the if is int function here, and I'll pass the value n. Only if it is true we convert or cast it to an integer, and we print the series. Else we put a message saying that please enter a positive integer only. Okay, so that's it. Let's try to run it again. We have added the condition to check for it to be an integer, and if it is not an integer, we are passing the message. So let's check. If we pass it 1.5, this time we get the right message, please enter the positive integer only, and it did not fall into the trap of giving us any other kind of error, the value error that we were getting previously. However, let's check for negative value. I think it will still be an issue because we haven't handled the negative values. So one way is to actually add another, either a function or some sort of check within the code in the main block. The other way, and I was particularly asked about this in one of the interviews, can I have an optional parameter in the function so that I can optionally check for the number to be both integer as well as positive. So how to do that? We will say, we'll add another flag called isPositive and default it to false, and we will check this flag once we have converted, or once we have tested that it's a valid integer. We will check if it's a positive integer. So is positive. Only if it is a positive integer we return true, else we return false. Okay, and yeah, that is it after we check for the number to be positive. But there is one more thing here. In fact, I haven't actually checked. I've just said that the flag is asking us to check, but I haven't actually checked it. So for that I will say if n is greater than 0, only then we should return true, else in fact we already have the else block. I just have to change the indentation. So Yeah, so basically now it's correct, where we have checked for the number to be greater than 0, that is positive, and only then we will return true, else we will return false. Else, if let's say we don't want to check for the number to be positive, then we are good. So return true. Basically all we needed to check is that the number is integer, which we already have tested here. If it stays in the try block after this step, that means it's an integer, so we are simply going to return true. In case of an exception, if it is not an integer, we are returning a false, and accordingly the user will get the same message, that is, please enter a positive integer only. Okay, so after making this change, also let's pass the flag here. So is positive, and I will, sorry, is positive, I will pass true, and let's see what happens now. So we are passing the value 1.5, it says please enter a positive integer only. We are passing a value -3, it says please enter a positive integer only, and we are passing the value 5, and it is giving us the appropriate value of 5, which is 0, 1, 2, 3, 4, 5. So let's in fact test some larger value here. So let's say I'm testing what is the value of Fibonacci number when n is 10. So 5, 6, 7, 8, 9, 10. So yeah, that's good. So this is how it works. Again, like I mentioned, I'm not claiming this is the best solution, I'm not claiming this is the only solution, but the way I have written it, that actually worked for me in one of the interviews, and specifically, like I mentioned, I was also asked to check for these edge cases, so that is where this function was really handy, and this optional parameter also is something that is a smart kind of thing to do, so that's why I wanted to share it. So that's it in this video. I hope this will be useful, and I'll continue making similar videos on other questions related to recursion and other topics that I have encountered. If you do like this video, please, if you do like what material I'm preparing or what material I'm sharing, please like the video, and also if you want to continue watching similar kind of content, please consider subscribing the channel. Thank you. Thanks a lot for your time.